Okay, I want to start off class by going over the remainder of our calendar for the semester. We're done with new material, but there's still quite a bit that we want to do to get ready for the AP exam. So along the way, we're going to have quizzes and tests, but those grades will be buffered by completion assignments that I'll be giving on a daily basis. So just to kind of give you a big picture, if you go to the back page, here are the remaining grades. Okay. So today we're going to be doing, we're starting this FRQ packet. This is really kind of a, we've done integrals before, but we haven't seen it quite in this form, and this type is going to be very common on the AP exam. So we're studying that for today and Monday, and then Tuesday, Wednesday, Thursday, we'll prepare for our FRQ quiz, which is a merging of a lot of second semester topics, and we're going to just kind of go through the same things so you can get comfortable, ready again, get ready for Friday's quiz, and then leading up to that. We're going to have homework assignments, and homework assignments, I'm just looking for you to do completion on a daily basis. Okay, so that will count for 25 points, and then that plus the quiz will give you 50-point test grade, and I'll put it under the test category. Okay, so it's going to kind of go in as like a half a test grade. Okay, and then after that, that week before spring break, it'll just be daily classwork and homework. I'll be checking daily, and that was going to go in the grade book as a 25-point quiz grade. Okay, so I want to give you guys incentive to do this work because you know it's going to help your grade. You know it's going to be entered into the grade book directly. Okay, I mean homework has been in the past, but just hasn't been as much with the practice category. But now putting it into the quiz and test category. After spring break, we'll have daily homework that's going to count for 25 points, and leading up to our second FRQ quiz, and that'll be 25 points as well. So another 50-point test grade will go in after spring break. And then that third and fourth week of April, we're just going to be preparing for a multiple choice test. The problem is that last week before May, it's EOC week, so all the class periods will probably be cut short to like 35 or 40 minutes. So I'm going to take that multiple choice test and split it into 2 days. So it'll be a 30-minute test on each day. First day we'll just be focusing on first derivative topics, and the second will be and the next day will be antiderivative topics, and all along the way. Doing homework on a daily basis, that'll account for half your test grade. Okay, so 100-point test grade will go in the grade book. And then finally, the first week of May is also the first week of AP exams. We're just going to be working through recent FRQs in full, so you guys can kind of get a taste of what to expect in terms of recent FRQs that's shown up. And that will be worth a 25-point quiz grade. I know students will be in and out during that week due to AP exams, so you can just turn in or show me your homework anytime. There's no late penalty for this last quiz grade, just because I know a lot of students will be in and out. You can just show it to me the week after if you like. Okay, so just kind of run through the calendar here. Again, today and Monday, we're focusing on these problems 1 through 6 on page 1 through 6 in your packet, and that'll be due on Tuesday. Okay, I think we'll get through a majority of it between today and Monday, but whatever we don't finish, you can finish out on Tuesday for me to check on Tuesday. All these assignments, I have the key on the website, so you can just work along the key if you want, or you can try on your own first and then check with the key. Okay, but on a daily basis, I'll be looking at your classwork and your homework as well. So what we do in class and each of the homework assignments, I will send out a daily reminder and also update the website so you know exactly what pages to do and what I'm checking, so that there's no, so you're not having to guess, what I'm going to be checking on that day. Now, as I'm coming around and checking your daily homework, I understand that sometimes you may not be showing the amount of work I'm looking for. So if it's not up to what I'm looking for, I want it to be robust. I want you to show the work of your problems. I don't want to just see answers, but if it's not quite what I'm looking for, then I'll ask you to finish it and show it to me later in the day. So what I mean by that is you can just take a picture of your finished work, and then you can either email it to me or you can send me pictures, and so that I'll still give you full credit as long as you show it to me on that day that I'm checking, even if it's later in the day. But just make sure that if you were to send anything to me through Remind, make sure you send me one photo at a time. If you try to put multiple photos and send it to me all in one text, it's just not going to come through. I'm only going to see the first page. Okay, so just send the first page, then take a picture, send the second page, and okay. Each of the homework assignments, I'm going to try to make it where it's not too long. It's going to make it front and back. So each homework is going to be, it's still a lot, I know, but I'm going to give you points in the test category. So, and it's going to be a natural buffer for your test grade. Now, I also understand that it's just not everyone's going to be able to finish everything on time because of your busyness. So, but I do want to give incentive for students who do finish their work on time, but I also don't want to penalize too heavily. So basically, the most I'll take off, per assignment, if you miss it or if you are late, even if it's 2 weeks late or 3 weeks late, the most I'll take off is 1 point per assignment. So even if you turn in all your assignments late, you're still, and if you eventually show me, you're still getting 80% for that grade. That's going to buffer your test grade. But obviously, I do want to give an extra incentive for students who are able to show it to me on time. Okay, so if you don't show it to me when I'm checking, you can still earn full credit if you send it to me later that day. Okay, even at night, as long as I have a record of it, I'll go back and I'll still give you full credit. Okay, we'll have a quiz next Friday. We'll practice those topics Tuesday, Wednesday, Thursday. The week before spring break, there's no assessments, but I'll be checking homework on a daily basis. After spring break, we're going to start preparing for our second FRQ. Our second FRQ will be the week, not the week after we come back from spring break, but the week after that, so the 19th. And after that, we'll start preparing for the multiple choice test. And then the multiple choice test this week is all going to be a little shortened. So we're going to split into 2 days. 26th will be the first multiple choice quiz or test, 8 questions, 30 minutes. And then Thursday, the second portion, 30 minutes, 8 questions. And then we'll do on that Friday, we'll kind of go over a lot of kind of test detail, exam details and exam tips. AP exam starts May 2nd, so a lot of students will be in and out of the classroom, but in class we'll be going through each of the recent FRQs in full. The ones that we don't finish, you will finish for homework. And then your AP exam for calculus is going to be Monday the 9th. Okay, after that, I'm just going to reserve these days for any students who need help sessions, assessment recovery, or turning in late assignments. Okay, so I don't have any there's no grades after this date. Okay. Okay, so I try to provide as much detail on the calendar. I'm going to update my website on a daily basis to match this calendar. I think I have it for the first week, but later weeks, some things are still mismatched. But if there's any changes with the calendar, I'll definitely give you a heads up through Remind and also a couple days in advance. Okay, any questions? So, I want you guys to feel prepared for the AP exam, but I also want to support your grade as well. I don't want your grade to suffer through this process, and the hope is that if you do your work, you'll have a nice natural buffer for these remaining assessments that we have in class. Okay, so if you guys can turn to, let's look at page 1 of your packet. No, this is I'm gonna check 1 through 6 on Tuesday. So today and Monday we're gonna get through most of the problems, but the ones that we don't finish, you'll finish for homework, and I'll check the first assignment on Tuesday. Yeah.
Will there be a place on your website for us to be able to check our work with?
Yes. So already on my website, I'll send out a reminder this afternoon or this weekend. I have an AP exam page. In that page, I have videos. I have all the blank worksheets. I also have keys. So yes, so everything I assign you, I already have the key ready for you. So so you just have to just show your work and just go through the grind of working through those problems, and I'll give you full credit if you do that. Okay. All right. Let's look at number 1. Just a couple of concept reviews for derivatives and integrals. You know that derivative is involving rate of change, and then integrals is involving area. And as you go through these processes, just understand that your units will just change, okay? So for derivatives, you're adding a rate. So for word problems, there's that denominator, that time is you're gonna have more units in your denominator. So for instance, if you start off with meters, the derivative will turn to meters per second, and then you find the derivative again to meters per second squared. So if you keep dividing by time, that unit will keep showing up. Okay. But then for antiderivatives, I think this is where I feel students have a bit more in terms of getting used to the units here. When you take the antiderivative, your units will also change, but you're moving up the chain. So for instance, if I start off with something that's meters per second, integral of v of t dt, right? Let's say v of t started off as meters per second. If you accumulate that rate over a time period, you're not going to end up with meters per second anymore. You're going to end up with meters, just in terms of meters, because you're multiplying by time. If you're multiplying by time, your meters per second times second will just turn into meters. So here's an example of a simple example that we can all visualize. If you were to travel 60 miles per hour over a 5-hour period, that's like saying the integral from 0 to 5 of 60, right? You would never say that, the result of that is going to be 300 miles per hour, right? You'll never traveling that fast, but you've traveled that amount of miles, right? You've accumulated that rate over a 5-hour period, so you're multiplying it and you're changing the units, okay? And if you go through a calculus process, integral of 60 dt, 60 becomes 60t, you plug in your upper and lower bound, you get 60 times 5, and you get that displacement, right? Change in position over change, or the change in position over the time periods, you get 300 miles. Okay, so that's just to highlight that every time we take the integral, we're going to expect our units to change. Okay, and typically what's going to happen is that your time unit is going to drop away. Okay. Okay, so let's read number 1, and then I want to kind of go through it piece by piece here. Okay. The rate at which people enter an amusement park on a given day is modeled by the function E, defined by E of t. So it's a messy function. We're going to need our calculator for this. Okay. The rate at which people leave the same park on the same day is modeled by L of t. Okay. But E of t and L of t is not going to tell us the number of people in the park. It's the rate at which people are either leaving or coming into the park. So both E of t and L of t are measured in people per hour. Okay, so understand that E of t and L of t are just, they're going to be rates, right? People per hour. Okay, and the time t is measured in hours after midnight. Okay, these functions are valid between 9 and 23. So the hours of operation is between 9 a.m. and 11 p.m. At time t equals 9, there are no people in the park. Okay, that's when the park opens. So part A says how many people have entered the park by 5 p.m., which in this case t is 17. Round your answer to the nearest whole number. Okay, let me just start off with an easier version of E of t. Okay, and then you don't have to write this down. We can kind of just want to kind of build this up. So easier version is, what if E of t was just 100 people per hour? Right. We know that, let's say, now this E of t is a lot more advanced, right? It's adjusting to the time of day. People per hour is not going to be the same over the course of the entire day. But let's say it were, then if I want to find over a 5-hour period, we know that the number of people that's entered the park is going to be 500. Essentially, we're multiplying, right? We're multiplying and we're changing the unit. So an easier version of this problem would be like this: 100 integral of 100 dt, right? If we accumulate that rate over that time period, this is just going to be 100t power rule. Now we're going to make the calculator do this for the more complex problems, but this is what's happening. Okay, so if you take the integral of something, you're multiplying the rate by time, and you end up with a unit that is different than what you started with. Okay. So this E of t is a lot more advanced because it's going to tell us, it's going to adjust for the time of day, right? The rate at which people are entering the park at 12 p.m. is different than at 5 p.m., right? And that has all that accounted for in this model. So let's look at part A. Part A says, how many people have entered the park by 5 p.m.? Now we know the people entering to the park is going to be related to E of t, but we don't just want to enter 17 in for E of t, right? Then we end up with people per hour, but we want the number of people, not the people per hour. So what do you think we can do? What can we do with E of t? Take the what? Not derivative, but take the antiderivative, right? We want to accumulate the number of people over this time period. We're going to practice entering this into the calculator. If you're using 36 Pro, then you just have to enter it in directly, manually onto your home screen. But if you're using 36 graphing calculator, I encourage you to enter it under Y1 for your E of t and Y2 for your L of t. So I have under Y1 holding that E of t function. If I go back to my home screen, I can just call that function without having to. So all I have to do is enter it in once, and I can just reference that function every time I use it, rather than having to type everything from scratch. Okay, so we're doing a running total, right? We're doing a running total of the people per hour, and we're just accumulating all those numbers over over our entirety of the day. So if you go to vars, yvars, function, y1. So round to the nearest whole number. So what does that 6,004 tell us? Yeah, number of people who've entered in the park over that time period, right? Between the hours of 9 and 5 p.m. Okay, any questions with part A? Okay, part B says the price of admission to the park is $15 until 5 p.m. But then after 5 p.m., the price of admission is going to drop to $11. So how much money is collected from admission to the park on that given day? Round your answer to the nearest whole number. So we basically have to find the number of people who've entered into the park up to 5 p.m. And then after we find that number, we'll charge each of them $15. But then between 5 p.m. to closing, we'll find those number of people and we'll charge them $11. And we'll add that up and we can find out how much money the park brings in through admissions. So we can create an integral for the $15 admission. So between 9 and 17 EFT, this is going to give us the number of people who've entered in the park, which we know is 6,004. So 6,004 people who've entered in, they're each going to be charged $15. But then the integral from 17 to 23, you can enter that in separately. That will tell us the number of people entered in the park, probably a lot less. And those numbers of people are charged at a smaller amount, $11. Make the calculator do the work for us. And we see how much money the park's going to bring in through admissions. Yes. Yeah, let me know if something in your calculator is not working out. I want to kind of make you feel comfortable with all the keystrokes that you need to do. Okay, so if you're not able to get this number, let me know. I can come in around and help you. Okay, any questions with A and B? Okay, let's look at part C. Okay, part C. Put this on this page here. Okay, it says h of t, let h of t be represented by the integral from 9 to t of e of x minus L of x. Okay, so that looks kind of abstract. The value of h of 17 to the nearest whole number is 3725. Find the value of h prime of 17 and explain the meaning of h of 17 and h prime of 17 in the context of the amusement park. Okay, let's go through this step by step. Okay. It says the value of h of 17 to the nearest whole number is 3725. Okay. We want to verify this, and we also want to kind of talk about what this means. So let's go ahead and enter 17 in for t, and then we can talk about kind of have a more concrete example to work with. Now, anytime we have an integral with a minus or plus separating, we can really treat these like two separate problems. Okay, and just for demonstration purposes, I'm going to split this up so we can kind of talk about each of these separately. Okay, kind of talk about, what does this mean? Okay, so we've had a taste of what this means here. What do you think? 9 to 17 integral of e of x dx, what does this represent again? Okay, you know that e of x is the rate at which people are entering the park. If we accumulate that, that's going to tell us what? Yeah, number of people who've entered the park between 9 and 5 p.m. Okay. All right. What do you think the integral of 9 to 17 of L of x is going to give us? Yeah, number of people who've left the park. Sorry. So if we have people who've entered the park minus, so what do you think the result of these two numbers subtracted will give us?
The amount of people that came into the park. The amount of
yeah, number of people still in the park when? At t equals 17 at 5 p.m. Okay. So if you accumulate all the people who've entered the park and you subtract those who've left, then what you have is the remaining number of people left in the park. So h of 17, they say h of 17 is 3725. And so the way we interpret it is we say that is the number of people left in the park at 5 p.m. It says t equals 17, but we know t equals 17 is military time for 5 p.m. Right? Okay, so that makes sense. Okay, so we're not done with part C yet. Part C also says find the value of h prime of 17 and explain the meaning of, we already explained the meaning of h of 17. And also, if you enter this in the calculator, you're going to get that 3725 to show up. Okay, we'll skip that step. But maybe it's a good idea, though, that you start entering, if you're using 84, start entering Y2 to be your L of T, because you're going to use it. Okay. Yes. Okay, let's look at that. Okay. This is small line thing. Okay. Okay. the rest of part C is asking for us to explain the meaning of h prime of 17. Before we get to h prime of 17, let's find h prime of t. All right, we know that h prime of 17 is asking about the derivative. So let's talk about how we can get to h prime and what it means. So h prime of t means I want to find the derivative, right? So h becomes h prime. If I find the derivative of this function, then this is what I'm going to do. Okay, I'm going to write down exactly what I want to do. I want to find the derivative, but I want to kind of show you what this is, what's going to happen here. Now, there's a little bit of second theorem going on here. What's going to happen if I find the derivative of a function that has an integral notation? What's going to happen here? These are what? Opposite. Yeah, these are opposite operations, right? So we know that these are just going to cancel each other out. And all I'm left with is just this E minus L. Now, a slight adjustment is that this variable do get plugged into that function. So H prime is just going to be E of t minus L of t. Okay, another way to think about this is when you see this integral of E of x minus L of x, that means you're sitting at a level above E and L. And the derivative is going to basically drag that function down to the E of x and L of x level. So derivative is going to basically take this upper level and bring it down. And when it brings it down, it's going to basically take that notation away and leaves us in terms of E of t and L of t. Okay. So now that we have a formula for h prime of t, we can now find h prime of 17. Okay. Practice entering to the calculator. There's no derivatives going on here. E and L are already in terms of a rate, so we know we're going to get a rate in return. So I'm just going to call my function y1, which is my E of x, and I'm just going to say I want every variable to get replaced with 17. Okay, now if you're using other calculator, you're going to have to just plug in 17 on your own. Oops, sorry, y2. Okay, that number doesn't really allow us to get a good read. So we can do is you can do you can do math, and then convert that fraction to a decimal. Negative 380. Okay, what is the units going to be? Or what's the unit of E of t and L of t? People per hour, yeah. So what do you think this is telling us about what's happening inside the park?
There's more people than the end between 9 and 5.
Okay, but this is talking about just at 5 p.m., right? So what's happening at 5 p.m.? Per hour, right? So this tells us that the population inside that park is shrinking by a rate of 380 people per hour, right? So E of t is the rate at which people are entering into the park. L of t is the rate at which people are leaving the park. If I subtract those, then that tells me the rate at which people in the park is changing. So H prime So we can say, like we said before, this tells us the number of people in the park is decreasing at a rate of 300 people per hour. But it's not for the entirety of the park, right? Just at 5 p.m. Okay, let's look at part D here. Part D says, at what time between 9 and 23 does the model predict that the number of people in the park is at a maximum? So now, if you think about a maximum or minimum and think about a graph, okay, what's a feature that you know that happens at the maximum of a curve? Slope is zero. So in other words, calculus term, we can say derivative is zero, right? Slope is zero, derivative is zero. So in this case, we want to set h prime equal to zero, right? Whenever h prime is equal to zero, that's going to be where the maximum is going to occur. So we know that h prime is E of t minus L of t. And if I set that equal to zero, then E of t minus L of t, this is going to tell me where the maximum is going to occur. Now, this makes sense algebraically and calculus-wise, but I also want us to think about, what this means, just thinking about this problem from a concrete standpoint, right? What is this actually? Why is this the case that when E of t minus L of t is equal to zero, why is this going to tell us the maximum number of people in the park? So let's think about E of t for a moment. Okay, E of t is the rate at which people are entering into the park. What's happening to that rate as the day progresses? Is that E of t growing, or is that rate increasing or decreasing as the day progresses? So compare 12 p.m. versus 2 p.m. versus 5 p.m. versus 7 p.m. The number of people entering into the park is getting smaller, right? Over the course of the day, that E of t, that rate is decreasing, right? What's happening with L of t as the day progresses? Are there more people leaving the park at 5 p.m. or at 10 a.m.? 5 p.m. usually, right? I mean, assuming that there's no special event. So that L of t is growing as the day progresses, right? So E of t is decreasing, L of t is increasing. And where's the maximum number of people is going to occur when what happens? When they're the same, right? That's where the maximum, that's when the number of people in the park is going to be at its busiest. Because eventually L of t is going to overtake E of t. And as soon as there's more people leaving the park than entering, then that park is going to start shrinking. So that's why when E of t and L of t are the same, that's when that maximum is going to occur. In other words, E of t minus L of t is equal to zero. Okay, so we're going to make the calculator find this for us. You can use numsolve on your scientific calculator. But we can also do this in our graphing calculator. We can create a Y3 and say, I want E of x minus L of x, and I want to graph this and see where it actually hits zero. Where does it actually hit the x-intercept? So we're going to graph this. Okay, and we're going to look for x-intercept. Okay. Basically, you want to see where is that graph going to cross the x-axis. And if you had to guess, when do you think, on a normal day, when do you think a park could have its maximum number of people? Sometime in the mid-afternoon, right? 2, 3 p.m. maybe. That's what you're expecting, right? Okay, so we're going to see if we can create that situation there. So if you want to graph it, make sure that that you unhighlight your y1 and y2. We really don't want these to be highlighted. So if you have highlighted equal sign, that means it's going to show up in the graph. So if you unhighlight it, that means it's still, you can still reference it, but it doesn't have to show up in the graph if you don't want to see it. Okay, so go to Windows. Let's adjust the windows a little bit. You know that the hours of operations between 9 and 23, so that's really all you need to worry about for your X's. And you may need to play around with your Y's. You see how these values are all the way in the thousands? So if we just do it from -10 to 10, we may be a little bit too zoomed in. We may not be able to see the curvature of the graph to trace it well. So I just went from -1,000 to 1,000 just to see what the graph would look like. Okay, and if you don't see a graph that is easy to interpret, you can always just keep changing those numbers until you get something that is nice to follow. So I'm just looking for that x-intercept. So that x-intercept, I'll do second trace, 0. I'm looking for the x-intercept, so I'll pick a point to the left of the x-intercept, hit enter. Scroll to a point on the other side of the x-intercept, hit enter. So 15.79. So that's around, 3 p.m., 2, 3, 4 p.m. So 15.794 is when the maximum number of people in the park. It's when E of t and L of t are equal to each other, and right before L of t overtakes E of t. Because after this point, the park's going to start shrinking. Okay, I'd like for us to try to get through another problem. So number 3, yes, go to number 3. So number 3 features a popular kind of line of questioning. So we're going to see this as we look at more of these types of problems. Okay, everybody good with? Okay. Okay, number 3, page 3. The tide removed sand from Sandy Point Beach at a rate modeled by a function r, given by r of t. Okay, make sure that we're dealing with trig here. We should always be in radian mode. Okay, so just double check that. Pumping station adds sand to the beach at a rate modeled by function s, which is given by s of t. Both r of t and s of t have units of cubic yards per hour, and t is measured in hours between 0 and 6 hours. At time t equals 0, the beach contains 2,500 cubic yards of sand. So this is the type of problem where we got to keep track of a couple of things, right? We got to keep track of the fact that there's an initial amount of sand on the beach, but then there's going to be this tide that's removing sand from the beach, but then there's also this pumping station that's trying to add sand back onto the beach. So all those things we got to be able to keep track of. Okay, and we're going to arrive at a equation or formula to help us with that. But let's do part A first. Part A is more straightforward. It says, how much sand will the tide remove from the beach during the 6-hour period? Okay, so we're removing sand here. Which formula is going to be useful to help us with that? R of t, right? But R of t is in terms of cubic yards per hour, but we're looking for the amount of sand. So what do we have to involve to convert this unit? We got to take the integral, right? The integral is going to allow us to accumulate that rate and make it rise from a rate up to just a physical amount. So we're going to take the integral of R of t. Okay, so we're keeping a running total of this rate over a period of 6 hours, and that will tell us the total amount of sand that's been removed over that 6-hour period. Okay, so practice entering into your calculator. Again, make sure you're in radian mode. And now something that started off as cubic yards per hour is going to rise up to just be in terms of cubic yards. All it says is indicate the units of measure. We don't have to provide any justification. Now, part B. Write an expression for y of t, which represents the total amount of sand on the beach at time t. So this is where this is a popular formula that we're going to use a lot with these types of problems. And let me write the formula first, and then we're going to adapt it for this problem. So there's three things we got to keep track of, right? That anytime we're talking about an amount, a total amount, there's always going to be initial amount, how much you're removing, and how much you're adding. So we're going to use this formula a lot for these types of problems. So anytime I'm looking for a total amount, I'm always have to involve how much is there to begin with, how much are you adding, and then how much are you taking away. Okay, so based off of this, we're going to see if we can adapt this for this particular problem. So let's let y of t represent the amount of cubic yards, the amount of sand on the beach. Okay, what's the initial amount? Yeah, 2,500. Okay, what's going to represent the amount I've added onto the beach? Okay, but S of t is a rate, so to get amount in terms of yards, I have to take the what? Take the integral, antiderivative. From 0 to x. Now the reason why we go from 0 to t and not from 0 to 6 is because we want to give it that flexibility, right? We want to create an equation that we can go back to and reuse for any time period. And also a slight adjustment, because the variable here is t, I want to use a different variable so that it can plug into that variable. Okay, typically we just want this to be a different variable. Typically we use x and then the t up here. So if this will tell us how much sand has been added to the beach, what's going to represent the amount removed? Yeah, similar notation, right? 0 to t r of x dx. Okay, part C real quick. It says find the rate at which the total amount of sand on the beach is changing at time t equals 4. Now it says find the rates, so we have to involve the what? Derivative, right? Derivative is rates, right? So if I want to find the derivative, y prime, let's talk about the derivative of each of these terms. 2,500 goes to what? 0. What's the derivative of this integral? Just s, yeah. So s of x, but then the t gets plugged in, so plus s of t. And the derivative of this notation is going to drop it down to just r of t. Okay, so real quick, if I want to find y prime of 4, the rate at which the amount of sand on the beach is changing, I can just plug into this formula, s of 4 minus r of 4. And the calculator will give us negative 1.908. S and R are in terms of cubic yards per hour, so cubic yards per hour. Okay, we're going to pick this back up on Monday. I'll be checking numbers 1 through 6 on Tuesday. Okay, but I will send out. I'll send out a reminder starting Sunday, daily reminder, so you know exactly when I'm checking the following day.